Okay, everyone. So this is day two of our numerical masterclass, right? Day two of week one. So let's start with the question. So again, I have arranged the question in a weekly format. So question six means that it is the sixth question of the week one. So there will be 25 question per week, right? And again, uh, in the next week, every week we'll have 25 question. Okay. So let's start with the question number six. So this question, it was a PYQ asked in 2024, and recently I have seen that ki UPSC is asking from those topics from which they have not asked questions from last 10 or 15 years, right? So one such of the topics is equation of motion. So again, this question is from the equation of motion, and UPSC is asking question from these topics. Even in 2025, you can see that they have asked question, right? So let's start with that. So a particle of mass m having have initial velocity v naught is subjected to a retarding force proportional to its instantaneous velocity, right? Obtain the expression for the velocity and position as a function of time. So exactly the same question, if you will ask any student of quantum yoga, uh, in that test series only 2024, I have given the same question, and exactly that same question come in the examination. I have done one small more thing in that question, that initial velocity projected upward. So the question that I have asked in the test series was better than the question they have asked in the UPSC. तो ये थोड़ा सा easy है. इसमें projected upward कर देंगे तो it will become a little more complicated because उसमें gravitational force आ जाएगा. Here retarding force is proportional to instantaneous velocity simply means that the total force. So I can write that कि F net external is proportional to velocity. So let's say minus alpha, alpha being the constant, alpha v, right? Now I can simply write this thing. This is the question that m naught, and it is projected with v naught. And after some instant, the velocity will become v, and this is what we have to find. And in this also, it will attain some position x, right? Again, there will be some time, so there will be t equals to 0. It is projected from x equals to 0, and here x is equals to x and t equals to t. We have to find v also, and we have to find x also. So it's very easy, you can do that. What you can write here, so it will be m dv by dt is equals to minus alpha v. Now you need to understand this is a vector format, and this is now I am written the scalar, right? So when we do the answer writing, I always tell students that you have to write that considering one dimensional motion in x axis or y axis, right? Some anything. See here, it doesn't mean that gravity is included here. Try to understand. Net force is this. Now it is very easy to solve. So what will be? It will be dv by v is equals to minus alpha by m. It will come outside dt. So what is the time from 0 to t, and what is the velocity will be? It will be from v naught to v. Now if you do it, it will be ln v by v naught. I hope you know the integration, minus alpha by m t, right? So what will be v? You know that exponential कर सकते हैं. So it will be v naught e to the power minus alpha m into t. Now again, I have told you that we are not going into the details of the we're not going into the details of interpretation, but from the result itself, you can understand that it is exponentially decaying. So these things you can write in your interpretation in the conclusion after writing the answer. So यहाँ पर लिख कर आंसर मत लिख कर आ जाना, right? Again, we are not this course is not meant for the interpretation, but again you can think on these lines. Also you can draw the graph. It will hardly take 5 seconds. That v, so there will be some velocity v naught, and it is exponentially decaying, so v versus t. So these sim a basic additional thing will fetch you more marks, right? This is the first part. Second part is to find out x. So again, v is what? V can written as dx by dt, which is equals to v naught e to the power minus alpha by m into t. Now we can write simply dx. Initially the position was 0. Now it is coming to x. Here it can be v naught integration e to the power alpha by m into t into dt from time 0 to t. So from here I can write down this integration will be x. It will be what? Minus v naught So it will be V naught upon alpha by m, V naught upon alpha by m, and here we will have minus e to the power minus alpha by m into t from 0 to t. So you can write that x will be equals to m v naught by alpha, and if you put t and 0, so it will be t 1 minus, because minus is already there, 1 minus e to the power minus alpha by m into t. Now again it is exponentially increasing, so you can write that also. This is how you can solve it. This was the easy one. I hope day 2 is relatively easier question we have on day 2, right? So always try to understand that you cannot, we have to use from the original law, right? So what can be the introduction, what can be the conclusion, again kabhi aur ke liye just focus on the numerical. See, if your numerical strength is very good, to understand ki what to write in the introduction, what to write in the conclusion will hardly take uh, 10 to 15 days of rigorous work. 10 से 15 दिन ढंग से काम करोगे, you will be able to understand कि interpretation क्या लिखे and introduction क्या लिखे. But if you fail to solve numericals, then it will be difficult. Okay, coming back to the next question. I think it is very easy question. A particle moves along a curved space C whose position vector is given R equals to find a unit tangent vector ET, right? So we have to find out unit tangent vector ET. So what will be tangent to a curve? Again, it is a very easy question. So tangent to a curve is what? Its derivative. Tangent to a curve, its derivative. So what will be derivative of this? So you can write here R is given RT as 3 cos 2t E1 cap. I know you know these are called bases, or you can also just like unit vector sine 2t E2 plus 8t minus 2 E3 cap. Now what will be its derivative? It will be simply dr by dt, right? dr by dt. एंड वी कैन सिंपली कर लो इसको, क्या ही कर सकते हैं इसको. हाँ, तो कॉस कोसाइन तो माइनस 6 कॉस 2t ई वन कैप. आई होप दिस इज द वेरी इजी वन. साइन 2t ई टू कैप, एंड इसका हो जाएगा 8 ई3 कैप, right? Now we have to find out the unit tangent vector. This is what you need to find out. Unit tangent vector ET. The unit tangent vector ET will be what? How we find out unit vector from a vector? So this is a vector. So unit vector is nothing but that vector by dt divided by इसका mod. I am intentionally not writing it as v because in the next part only we have to verify कि v is equals to vat. So that's why I'm refraining from that. Okay. Okay. So this will be, what will be the mod of this? So now let's define v is equals to dr by dt. So let's find out here. So it is 6. So root under minus 6 cos 2t का whole square plus 6 sin 2t whole square plus 8 square. Now you know that cos square plus sin square theta is equals to 1. So it will be 36, it will be 64. So ultimately it will be 10, right? Now if you divide this by 10, what you will get? So 6 by 10 is minus 3 by 5. So minus 3 by 5 cos 2t even this will also become 3 by 5 sin 2t e2 divide by 10. So 10 से करेंगे तो ये हो जाएगा, it will be 4 by 5 e3 क्या. Now this is your v, this is your et. We have to find v, right? So what is v? V is this one. This is how you define v. Just write it down. V is equals to this, And what is this? This can simply be written as, if you take 10 as common, if you take 10 as common, it will be like this. Time pass है ये question, right? What is this? This is V, this is ET cap. So hence proved. Okay. So if it is what was your original launch classes, I will never solve this. But क्या कर सकते हैं, यूट्यूब में सॉल्व करना पड़ता है. तो ठीक है. This is what we have proved. V is equals to ET. So one more thing, please do not ask for the PDF, right? If you are not able to solve any question, just go to that question only. सारा वीडियो देखने की जरूरत नहीं है, right? Even it is on YouTube, uh, watch only that video that is relevant to you. ठीक है? Okay. Now coming to the next question. It is coming from the Coriolis force. So we have to find out the horizontal and vertical component of Coriolis force. Now if you are following my notes or foundation batch notes, any of my batches, I have told you guys that key for Coriolis force, please try to understand there are something basics that you have to understand, and please follow that क्या कह सकते हैं notation always. So it will help you to make question in a very easy format. So let's say this is our earth, and this our earth is divided into various of the latitudes, we know that, right? And this we measure from the this angle center, let's call it as lambda, right? Now earth is also spinning from west to east with omega, and such that ki omega is equals to 7.3 into 10 to the power 5 radian per second, because you will be needing this data in this question also, and this data you should be remembering, right? I hope most of you do that. Now one more thing apart from this, please try to understand ki how, because in the question they will give you east, west, north, for example in this question only heading the east, right? So we have to devise one mechanism or the reference frame to convert this east or west or something in a vector notation. So let's do that. So this is my horizontal surface on earth. Okay, and this is what I am writing as x, this is what I am writing as y, and this is what I am writing as z. Now z is nothing, it is the vertical, that is, it is up or down. समझ आ रहा होगा, I think that this is our earth surface, right? In earth surface we have north, we have south, we have east, we have west, but we can ऊपर और नीचे भी, right? So ऊपर नीचे we are doing into z coordinate. In x and y we are doing with the east and the west, again positive x east, negative x west. In this also north and south, positive y north and right. So if you will do that, obviously from the center in this direction you will have z, यही ना है, this is z, right? And tangent to this you will have y, and this will be your x. I'm just writing so that you can understand this. And if you convert it, you will have omega is equals to omega cos lambda. Again, I'm not going to teach these things because this class is not meant for that. And I hope you know these formula, sine lambda k cap, right? So use this omega always, right? Where you know that ki what does j signify, what does k signify, right? So first step is this, right? If you don't know, you can just check your notes or wherever from you have studied, or खुद से हमसे पढ़ा है तो you can check the notes or the video. We have explained this thing in great detail, right? But let's come to that ki you know the formula that omega is omega cos lambda j cap and omega sin lambda k cap, right? Now what next? Formula you know that the F Coriolis is what? How you define? It is 2m v rotational, that is the velocity of the object with respect to the rotating frame into the angular velocity of the rotating frame. Or you can write at minus 2m omega cross v root. जो भी पसंद है तुम्हें, you can use. So this is the second formula. I hope you know that. Now apart from that, what you have to do here, that lambda is your latitude, Now these information we have. Now with these information, let's try to solve this question. So bird of mass m, mass 2 kg. So m is given 2 kg, right? Latitude L is given 60 degree, right? Can you write V? So flying at 10 meter per second at a latitude 60 degree, heading east. So I can write that V is equals to nothing but 10 I cap. The value of V is again 10 I cap. Obviously, you know that V cap we can write like that. है ना? So this is the direction I cap because east X I cap. You know that V. Now use that thing. What will be FC? So it will be 2m I cap, J cap, and K cap. It will be V 0 component here 0 omega cos lambda and omega sin lambda. Now you can say that if I take I cap, what will happen? This multiplied by 0, this multiplied by 0, so we have 0. So no force is applicable in the east or west direction. X में नहीं हो रहा. That means it will not change the magnitude of that. It will be rather a deflective force. समझ में आ रहा है ना? जिस डायरेक्शन में बॉडी मूव कर रहा है उस डायरेक्शन में अगर फोर्स लगे तो इट में retard or it may accelerate the motion, but it is only a deflection force. You know that. So the component is 0 in the I cap signifies simply that it's merely a deflection force. Okay, so coming to minus j, what we can write here? So minus j, what you can write? Omega v sine lambda into 0. So it will be omega v sine lambda 0 plus k cap. Similarly, what we can write? Omega v cos lambda, and all of this is multiplied with 2m bahar hai, so 2m. So what we can write here? So the F vertical of Coriolis force. F vertical of Coriolis force is what? The K cap, right? So it can be simply 2mv omega cos lambda K cap. Now mv everything is given. If you put all these value, it is coming out to be 1.46 into 10 to the power minus 3 Newton, right? Again, I also teach key interpretation may you when you are having any result, you should be able to interpret it. So here interpretation can be two things. First, the direction. Direction is k cap. That means it is acting upward. Vertical Coriolis force is acting upward. That means if a bird is moving, it is giving a upward thrust to it. And again, this value is very small, and that's why we know that the Coriolis force doesn't make sense for small object. It is mainly for heavier masses like air mass. When you study in geography and all those things, so air mass, river system. So when you have a large mass, then इसकी वैल्यू कुछ होती है. It is significant. Otherwise, this force is very insignificant. You can understand कि vertically, you can understand. Just compare it with the gravitational force. So 2 kg, that means 2g, that means 20 Newton का फोर्स ग्रेविटी लगा रही है. एंड इट इज हाउ मच? यू कैन अंडरस्टैंड दैट. सो ये 20 न्यूटन का फोर्स है एंड दिस इज लेट्स से 2 है, 2 इंटू 10 - 3. सो इससे कितना बड़ा? 10,000 मोर्स is gravity. That means this Coriolis force is 10,000 times smaller than the gravity. That means it's a very small force, negligible force, right? Again, these things थोड़ा सा होना चाहिए. I have to restrict myself because I have told you कि I have to make video within the 30 minutes. But again, थोड़ा थोड़ा जो है I will try to give you. So 2mv omega cos sine lambda j cap minus j, right? Let's write it together. Minus j signify what? This is the direction of, obviously. So j is north, so minus j is southward. So southward deflection is there, and if you write it, it is coming out to be minus 2.528 into 10 to the power minus 3 Newton. Again, it is a very small force, but even if you have to consider both, you can understand that it is twice the vertical force, right? So this is what we can understand from this question. So this is a very easy question, but this play a major role. So if you are able to write the velocity in this format and omega in this format, it will be really very helpful in solving All the questions of the Coriolis force. Okay, coming out to the next question, ninth question. A body of mass m traveling, a boat of mass m traveling with velocity u when the boatman stopped rowing, assume the driving force due to the water to be alpha e to the power bv at velocity v. Find the time required by the boat to stop. कितना टाइम में रुक जाएगा? Assume water to be stationary. Now, if water is stationary, दैट मीन्स ये बोट लिखो, बॉडी लिखो, कुछ भी लिखो, कुछ ना लिखो, कोई फर्क नहीं पड़ता. बोट, बॉडी, ऑब्जेक्ट, एवरीथिंग मीन्स सेम. बट इफ the water is not stationary, you know that you have studied the concept of upstream and downstream, so you have to apply the upstream and downstream concept. But ठीक है, it is an easy question. Here you don't have to utilize the upstream and downstream concept, so you can write simply. So this is again equation of motion. I can simply write that the net force, that is m dv by dt, is given as this retarding force due to water is alpha. So alpha e to the power b v, right? Now assuming one directional motion, ये vector symbol भी हटा देते हैं, है ना? I hope you understood till now. So dv by e to the power bv will be equals to alpha by m integration from 0 to t dt, and it is from initially u 0, sorry, it's minus why? Because retarding force, right? Whatever the dv by dt is, it is going down, right? That means it should be negative here. Starting force, it is minus alpha b to the power bv, just like in the first question that we have done. Similarly here, so when you integrate it, so it will be what? E to the power bv. Or if you're not comfortable with this, write like this. I have seen people are not comfortable with this notation, but I think this is fine. So minus alpha by m into t. So this will be what? It will be e to the power minus bv. I am going extremely slow and as basic as I can. Alpha t, sorry, minus b also. So minus and minus will cancel from this side. So this will be, if you put here, it will be 1 minus e to the power minus bu here, and here b will come upper, alpha b by m into t. So here you can simply write that ki t is equals to m upon alpha b 1 minus e to the power minus bu. So these questions are very similar in nature, but I want you have to have the strong hold on these concepts, because again and again UPSC is asking from these sections, right? So you should be knowing that how to approach this question. That is very important, and mainly the exponential retardation are a good thing for equation of motion. Okay, so let me know if you're able to understand this or not. If you want to, uh, if you need a more speeder version or you want to slow down, whatever you need to do, you can just comment it. ठीक है, अच्छा लगे बुरा लगे जो भी है, you can, uh, it will really help me to get the feedback, because in the online classes I will be able to understand from the student response कि सॉल्व कर रहा है नहीं कर रहा है ना? सो इन द क्लास आई एम एबल टू अंडरस्टैंड कि क्या चल रहा है, बट व्हेन आई एम डूइंग इन द रिकॉर्डेड मोड, इट विल बी, आई वोंट बी फाइंडिंग कैसे पता करना है इस चीज़ को, राइट? सो इट विल बी हेल्पफुल फॉर मी इफ यू विल राइट इन द कमेंट बॉक्स, राइट, कि वेदर यू आर एबल टू अंडरस्टैंड और नॉट. इट इज़ वेरी इंपॉर्टेंट. Okay, so let's get down to the question number 10, and it is the question from a two-stage rocket, right? Now I know that you have solved most of the question from the single stage rocket, right? But I wanted to give you a two-stage rocket question because it might come in the examination. Okay, I have a good, but even uh, if it's coming in the examination, you will be one who are able to solve it. And because it is not a very far-fetched concept, it is coming from the single stage only. The same thing you have to apply twice, right? And you have to find the final velocity of the rocket. Exhaust velocity is given and weights are given. Okay, first try to understand. I want to give you. So this is coming from the rocket motion. This is coming from the rocket motion. Now you need to understand few things. That if this is my rocket, it will have two stages. like this. This is the first stage, let's say, and this is the second stage. एंड तुम लोग जीएस में ही पढ़े हो यार, है ना, यू आर डूइंग फ्रॉम द यूपीएससी, तो यू आर ऑलरेडी वेरी अवेयर विद दीज थिंग्स फ्रॉम द साइंस एंड टेक मॉड्यूल. सो फर्स्ट स्टेज, it will have some fuel plus some structure weight, and similarly the second one also, it will have some fuel weight and some structure weight. Obviously, now you need to understand the two stage rockets separately weigh 10 100 kg and 10 kg, 800 gram and 90 kg of fuel, right? So what will happen in the first? So पहले क्या होगा? Exhaust is taking place. So first what happens? First fuel gets end, and then rocket eject the structure. First fuel gets end and then rocket eject the structure. समझ में आ रहा है कि पहले फर्स्ट स्टेज का पूरा फ्यूल इजेक्ट होगा एंड देन इट विल इजेक्ट द रॉकेट. ठीक है, इट्स अ टू स्टेज, सो हाउ इट विल हैपन? सो ट्राई टू अंडरस्टैंड. इन द स्टेज वन, ये सेकेंड से ज्यादा बन गया, थोड़े छोटे कर लेते हैं. ठीक है, सो इन स्टेज वन व्हाट विल हैपन? एट दिस टाइम, एकदम इनिशियल है, this is the second stage, this is the first stage, and it is now taking off, right? So it is where it is taking off. So when it is taking off, what will be velocity? It will be zero. At taking off, the velocity will be zero. Okay, now try to understand one thing, what it will do next. So first it will exhaust all the things, right? Now what will be the mass? So let's take m naught is the mass at this time. So what mass it has? It will have all the weight of this structure and fuel, right? So let's write down the two stages rocket, 100 plus 10. So it will have 100 plus 10, right? These are the structure, and then it will have 800 plus 90. 800 plus 90. This is my fuel. And you understand now? This is for the first structure. This is for the second structure. First, second, first, second. Now I'm going a little bit slow because some of you have not studied these things concept, है ना, तो थोड़ा सा समझ ही लो. Now what will be total weight here? So it will be 1000 kg. Now what will happen in the first stage? So in first stage, what will happen? It will burn all the fuel, right? It will burn all the fuel, and now it's time to come to this stage. Here with fuel, here without fuel. Now let's take here the speed was v, right? Here the speed will be v1, and let's say v0 इसको मान लेते हैं ना, इस टाइम पे कुछ भी स्पीड रहा होगा, let's say. Although it's taking off, the v0 is 0, but let's take is v0. So it is going with v0. Now it is v1. Try to understand what I am trying to say, that at this time it has not ejected the first one. Now what will happen in stage 2? And this is very important to understand. In stage 2, it will get a read of the stage 1, but it will always have the second stage, and it will have fuel. So what will be velocity here? Can I write v1 So no. So this stays, the velocity will not be equals to v1. Please try to understand. This is very, very important to understand. Now understand what will be mass here. So I am writing is it as m1. So it has exhausted all the fuel. That means this part is gone. Now what is remaining? 90 plus 10 plus 100. That means it has 200 kg. Now it has 200 kg. Okay. Now coming to the second stage. In this stage, it has exhausted all the, it has gone through, ये फर्स्ट वाले भी हटा दिया है. अब देखो एक चीज समझो, इस V1 और V2 के बीच में भी एक स्टेज आएगा V1 डैश वाला. ठीक है, ट्राई टू अंडरस्टैंड दिस थिंग. पहला फ्यूल खत्म किया, फ्यूल खत्म करने के बाद इसकी वेलोसिटी V1 थी. ठीक है. नाउ अब इसमें एग्जॉस्ट नहीं हो रहा है, समझो जैसे, एंड दैट्स व्हाई वी हैव टू कंसीडर टू सिचुएशंस. पहला एग्जॉस्ट करके यहां पहुंचा, अब यहां पर एग्जॉस्शन नहीं होगा, यहां पर ये इजेक्ट होगा, एंड जब ये पोर्शन इजेक्ट होगा इट विल गिव मोमेंटम दिस टू मूव अपवर्ड. ठीक है, आई होप यू आर एबल टू अंडरस्टैंड. दैट मीन्स फ्रॉम द V1 after the ejection of first one it will get V1 dash. ठीक है. Now then it will come to a situation when it will have only this component. So what I can write here, I can write here mass as m2. Here I can write the mass as m2. Now what will be the mass here? So it will have, get rid of this structure. ये जो स्ट्रक्चर है, ये पहला वाला स्ट्रक्चर हट गया है. So it will have only 100 kg. It will have 100 kg. Let's say इसको m1 dash कर लेते हैं, बेटर है. And now what will happen? So it will be in this position that it will be exhausting, and it gets of the second wall part. ठीक है, that means no fuel is there, bullet right. And let's call this as V. So what will be mass here now? M2, let's say. So at this position, what we have done, we have exhausted the last fuel. So what is the structure weight is 10 kg. Now you need to understand this thing. Please try to understand this whole process. You'll understand that we have to take only the जब exhaust velocity काम कर रही है, structure हटना वाला we are not counting it here. ठीक है. So in the first stage what is happening, that all the fuels are burning, and after the burning of fuel it will eject out 800 gram जो fuel का weight है. ठीक है. So let's say V0 to V1 it has gone. Now in the second stage again it will have some velocity, it is also exhausting. So यहाँ से यहाँ तक fuel खत्म. ठीक है. So try to understand कि for this fuel first gone, and from this fuel 2 gone. Now let's do with this. I have to teach you one more thing, that in cases for the rocket motion you have to study two cases. One is with gravity, we have to consider gravity or not, and one is without gravity. Now without gravity no rocket motion is possible, you know that, right? Everything is happening within gravity. But which case we have to consider? So if it is with gravity, if time is mentioned in question, I have told you now, I will be telling you the approach also. If time is mentioned in the question, let's say 10 second, 20 second, that we have seen earlier in earlier numericals, right? If time is mentioned, then we can write. But if time is not mentioned, we have to do the instantaneous analysis, just like in this case. We will go with the without gravity concept, right? So what we will write, I'm going with the scratch only, right? Considering upward as positive, downward as negative. We know that this we have done yesterday also. F external is equals to m dv by dt minus u dm by dt, right? What was that? It was mg. Net external force was mg, and this is m dv by dt minus u dm by dt. Now you need to understand the time that we are taking here is very less. So let's do this. So g will be dv by dt minus u by m dm by dt. So let's write dv. Again, we are considering this dv wala part. So it will be again v naught to v, and this g will be g into dt from 0 to t, g vector, and this u will come outside and it will be dm from m, right? It will be m initial to m final. So if you will write, if you integrate it, you will have v naught, v is equals to minus v naught, इधर ले जाओ, v naught plus gt plus u ln mf by mi. Now you need to understand what all are 0. V 0, याद करो, take off 0, and this thing is 0. Why? Because we are doing instantaneous analysis. Otherwise you have to calculate the time also, right? That will become very tedious, and that is not the case here. So in rocket motion you have to understand ki when you have to take the gravity case or when you have to not. It's just upon whether time is mentioned or not. So ultimately you will come to this conclusion that v will be equals to u, let's do it later, do so. Let's do it later. V is equals to V naught, that is the initial speed, plus U ln mf by mi. So what I can write in the first stage? So first stage, I can simply write that it is going to get V1 after the exhaust. याद रखना, it is the velocity gaining only due to the exhaustion of the fuel. Fuel खत्म हो रहा है तब ये velocity आ रही है. So it will be have U. What was that? So we can write here. Earlier we are having m naught and then we are having m1. So m1 by m naught. Now what will be v2 or final v? So final v, again, final v, we are taking from this, and we are saying that this process is very instantaneous, and this is my v1. Please try to understand, right? What happened actually, that if first one is ejected out, it will get some v1 dash speed, but we are not doing that thing, right? Because we are going to do the instantaneous analysis. So we are just saying कि v naught से v1 गया. We are just saying that v naught से v1 गया and v1 से v गया, and only the things we are considering is the exhaustion of the fuel. ठीक है? So we will be able to get v is equals to v1 plus u, and what will be ln? So ln again we will take from this to this. It is what? m2 by m1 dash. m2 by m1 dash. We have finally written everything, m2 m1 dash. Please try to understand in real life what happened from this to this, velocity gets changed, right? So please try to understand the assumptions involved. That's why I am writing multiple times. The first assumption is that it is so instantaneous that we are considering even if this is ejected, we are not considering it, because in this whole rocket motion the only concept that we have used is the concept of variable mass, right? So exhaust velocity is important. Try to understand. All the formula that we have built is based on that only. I hope you know from your classes only. Okay. Okay. So put the value. So if you put the value, see V will be equals to V naught. V1 is equals to V naught. U, I will take it common. Ln M1 by M naught plus ln M2 by M1 dash. You know that. Now this V naught is 0. We know that. Initially बताया ही है. तो कर लेते हैं. So U, let's write the value now. So V and U is exhausting downward. So let's say it is minus j cap. नीचे आ रहा ना U. So U is minus j cap. So U into minus j cap, and here you have ln, multiply कर दो. So m2 m1 upon m1 dash m naught. So if you put it, U is given as 1.5 kilometer per second. So U is given as 1.5 kilometer per second. Here ln m2, so it was 10, m1 was 200, m1 dash was 100, and m0 was 1000. So if you can see here, m1 was 200, m1 dash was 100. Okay. So 0 0 gone, 10 10 gone, and 2 2 times 50, and it is minus j kilometer per second. So you know that ln 1 by 50 can be written as 50. So 1.5 ln 50 is the answer. J cap. Right? You know that the rocket is moving upward. If you solve it, it is coming out to be 5.868. Right? So I know this question is a little bit tougher side. If you are not able, if you have not solved it earlier, you won't be able to solve these types of question in the examination, at least. Okay, so always try to understand on two things that is very important. First is the what cases we have to use. Don't get confused. When time is mentioned, we have to use gravity. When time is not mentioned, we have to use the instantaneous case. And the second thing is we have derived this thing, this formula for ejection of fuel. So please try to understand the limitation, because rocket, we all know, we have studied rocket in the science and tech also, so we know कि rocket कैसा काम करता है, right? But you have to understand कि what are the limitation on our formula, right? So that's all for this. In the next video we will cover the day 3. Thank you everyone. Bye bye.